So I was asked to present the state of the science background, or this is a document that CAP had Golder start working on actually back in 2004. And it's a bit of a living document that we keep updating. Yesterday's discussions were great. They did cover a lot of my topics to talk about today. So I'm going to move fairly quickly through this. Again, it's just a reminder of what we've got. I'm going to focus on Alberta caribou. The document itself has focuses on areas where the oil and gas members of CAP have development, so northeast BC into the mountain areas and Alberta, with a bit on Saskatchewan and the territories. But I'm going to focus primarily on Alberta. A bit on why the State of the Science document was prepared to begin with, and then dive into pathways to decline based on the literature, and then just do a bit of a summary on those pathways and how they lead us into recovery. So as we learned yesterday, we have a threatened species with a lot of population declines, particularly in Alberta and northeastern Alberta. Governments and stakeholders have been responding, but as Elston identified, we've spent a lot of years and have quite the paper trail behind us, so we're ready to get on the ground. There is a lot of knowledge to inform recovery planning. This figure is from the West Central Alberta Caribou Standing Committee. A similar figure was produced from the Athabasca Landscape Team in Alberta, and in those planning team workshops with caribou specialists at the table, the science that we have helped us inform the modeling approaches and where we see the tools in our toolbox that are going to be important to bring caribou back. Having said that, there are gaps that have been identified in those exercises, but it was interesting when we did the last update on the state of the science, a lot of those gaps have been starting to be filled, particularly around the predators and alternate prey question. So there's multiple pathways, as you can imagine, into caribou. We heard some yesterday that we don't typically consider, or historically for caribou haven't been considered too much, including the importance of lichen. It's generally been assumed that they've got lots of food. So what we did originally in this State of the Science document was gather all the information and look at what the pathways are, and why that was triggered was because caribou population trends were found to be negatively correlated with total disturbance within population ranges. So industry wanted to grasp, okay, what does that mean from us and what does the science tell us? And of course there was the Sorensen and BCC habitat target, which was again looked at by Booten and Arianti. And then Sleep and Lofley, I don't know if I'm saying that name right, revisited it with herds across Canada, but it wasn't found to be very strongly correlated. So, but a very strong correlation in Alberta. And then when Booten looked at it, there's some qualifications around how that equation should be used, those are important things to consider in recovery as well if you're using. So caribou populations in Alberta, we talked yesterday, census techniques are limited in the boreal, but we do have these realized population growth trends which have been measured through systematic monitoring. A number of the herds in Alberta, probably about half, have got this 14 to 16 years worth of data, and every herd's had collars on it now, and probably Dave, correct me if I'm wrong, but probably the ones with the latest collars have still got 2 years of data or more. And these trends, what we have the data on is adult mortality and calf recruitment data. And there's long-term population declines in Alberta, and this is just one of several figures from the updated status report. This is the east side of the Athabasca range, and you can see right around that 2000 time period when we started to see a lot more intensive development, quite a sharp decline in the trend data. This is similar to some of the other northeast Alberta ranges since the late 90s. So Cold Lake Air Weapons Range has declined by 74% since '98, and the west side has declined by 66%, and that's where Dave Latham did his work, and we've seen the increase in predators and prey. So the first pathway to decline that the science points us at is mortality, and this is adult calf mortality as well as the implications of altered predator and prey dynamics on that mortality. So based on the trend data that we have and the surveys that have been done in Alberta, annual adult female survival seems within the natural range from other jurisdictions in Canada, so within that kind of 15% range. The average, when I averaged them out from the latest stats report, is 86%. McLaughlin had 88%, and I think it was Stan yesterday that pointed out it's not something that we throw away and we don't look at it. It's very important, and this is something that could be trending downward. The mechanism for that predation is, the mechanism for that mortality is predation. There have been instances in herds in Alberta where vehicle collisions, for example, the alopesh, that was at one time an important pathway for mortality, and harvest possibly could have been. But right now, what we're learning is it's primarily this predation mechanism. Jess Dunford, when he was with the Boreal Caribou Committee, did some analysis on where adult mortality was occurring and found it was correlated to proximity to linear features. Kirby Smith, in his thesis, reported a negative correlation between industrial activity and adult survival. But interestingly, Dave Latham's work, which had 42 mortalities that he looked at, there was no significant difference in distance to linear features between adult female caribou mortalities in live locations. What Dave found is that caribou tended to die where they lived, so if they live in peatlands, that's where they're tending to die. But that could be some encroachment of the predators in there. Leila Neufeld looked at the spatial separation of wolves and caribou and saw there's a decrease in the spatial separation in the summer months or snow-free months. And wolf distribution was highly influenced by distribution of seismic lines. And adult mortality events appear from the literature to be greater during that snow-free period. And that's when our boreal ecotype in particular has reduced movements and smaller home ranges. So for calf mortality, I don't think it was talked about yesterday, but caribou do have naturally low recruitment rates. So we're not talking about an ungulate like deer or moose that can have twinning or to kind of rebound quickly. So this is a critter that's evolved to have babies, but not at a very fast rate. They do have high pregnancy and calving rates reported on our ranges, but the mortality of those calves, it's very high, and it's occurring very early on, so within kind of the first 4 weeks of life. So that's a very critical time period for us. Bergerud put out the notion that if we have 12 to 16% calf recruitment, we'd have stability, and essentially that's replacing, I think it was Dale mentioned yesterday, we need to replace the adult mortality with calf recruitment. I know Environment Canada in the recovery plan has a higher number in there. Factors for the calf mortality are primarily predation, and not just wolves here. We've got, bear being a large predator, as well as wolverine and eagles, and possibly others like coyote. There could be some abandonment, but that's a bit of an unknown on how much that would be, and then possible severe weather. When Jess looked at some of the calf survival and seismic line density, he saw no correlation between the survival and seismic line density. And we've seen some success of predator exclosures. So there was some work done in the Chisana herd up in the Yukon that was carried on to a pilot project in Alberta in the Little Smoky. It's undetermined if it was successful or not, because the same year that the penning was done, there was a wolf control program implemented, and the caribou calves that survived into recruitment age from the pen were about equal what survived outside the pen. So it's hard to say how successful it was, but there was reduced predation on the system. And based on the fact that we don't have enough calves recruiting into the populations, these high calf mortality rates are contributing to the caribou population declines. Darren Sleep presented yesterday, and Nikasi has, as he mentioned, is looking at how the disturbance footprint influences female nutrition, energetics, and overall body condition. And this could also influence calf survival. So we talked a lot about this yesterday. There's a few presentations, altered predator-prey dynamics, so increasing primary prey quality populations and range overlap with caribou, and can lead to increasing predator populations and range overlap with caribou. There's Adam James looked at, in the mid-90s, looked at predator efficiency on lines and found that wolves were traveling faster on lines than in the surrounding forest. And then ultimately being an increased predation rate and risk to caribou from the altered dynamics. Environment Canada has identified that predation is a major factor affecting boreal caribou viability, with the primary predators being wolves and bears, although they're not considered a primary prey species. And one of the presentations yesterday had Bergerud's hypothesis, if you will, or theory that if you've got greater than 6.5 wolves per 1,000 square kilometers, that caribou populations will decline. Hellowite actually has published that that number could actually be lower than the 6.5. One of the studies that Stan went over yesterday, Adam James's work back in the mid-90s, and then a comparison to Latham, just want to revisit that. So when Adam James did his work, wolves were at about 6 wolves per 1,000 square kilometers, and moose were 10 to 20 per 1,000 square kilometers. When Latham went back in about 10 years later, and we're in an area where with a lot more intensive development, there was no real change in those moose densities, but deer have increased substantially, and this is in the west side Athabasca range. And there's been a significant overlap in wolf ranges with caribou, as Stan pointed out. So we've gone from 17% overlap to 41% overlap. And the wolf number changes are quite extensive. So we've gone from 6 wolves to 10 to 11 wolves per 1,000 square kilometers in that system over a 10-year period. There's been a shift in diet of those wolves to deer in the winter and beaver in the spring. And wolves, their distance to rivers and streams, the distance to rivers and streams and beaver occurrence were important variables in the location of caribou mortality. So as I mentioned, caribou are tending to die where they live in the peatlands. So there's been quite a bit of work on predator-prey dynamics. Nicole McCutcheon looked at a modeling exercise and was looking at this movement efficiency of wolves, and found that it seems to be more related to the number of predators in the system rather than just the movement efficiency increase from the impact of linear development. There's a few studies that show that we've got this spatial overlap between wolves and caribou greatest during the snow-free period, and of course that's when we've got our neonate predation. There's been a bit of work using Sophie's data from Cold Lake Air Weapons Range on black bear foraging in peatlands, and then some work done in northeast BC as well. So we've got the odd black bear venturing out into peatlands during that neonatal period. Latham also just published a report looking at coyote expansion in the boreal and incidental predation on caribou, so a small portion of caribou in their scat. Kim Daw, as Stan mentioned yesterday, looked at this white-tailed deer presence related to climate change, and found that white-tailed deer presence is positively related to the land use footprint, deciduous forest, and growing season length, as well as negatively related to winter severity and wetland cover types. So the second pathway addressed in the State of the Science is related to habitat loss. Not going to say a whole lot here other than, For a long time, we've thought that the direct habitat loss is not believed to be a factor in caribou population declines. I think it's probably range specific. Dale gave an example where that maybe, if you're going to mine all of a mountain caribou range, then it probably is. So forest harvest and peat harvest schedules, as well as intensive development, you know, we should consider that they may not sustain lichens, and continual reduction in the amount of contiguous old forest would contribute to the amount of alternate prey. Fires have been shown that they don't alter caribou distribution or range fidelity. That was just Dunford's work. However, fires are an important equation when we look at these habitat effectiveness targets for caribou, so still need to be considered, and when we consider it, we need to consider what fire does to the ecosystem. So again, it kind of relates back to that habitat for alternate prey and change there. So in Alberta, there's the research on caribou, besides looking at ranges and populations and ecotypes and kind of the basic biology, really started to take off on more applied research on industrial development, with the thought being that there's a sensory disturbance going on from the industrial development onto caribou. So this is kind of pathway 3, so this indirect habitat loss to caribou. So Bradshaw looked at actually seismic exploration and found temporary avoidance of those activities. A lot of work was done on the avoidance of physical disturbance features, so buffering these disturbance areas and looking at how much caribou use is in those buffers versus random use. There's reduced habitat use, if you will, around a lot of the linear and human development footprints, but sometimes that use is dependent on the individual animal. And there appears to be disturbance differences in the type of use. So, for example, a caribou is going to respond differently to a well site in the summer and winter versus how they're going to respond to a seismic line that might have some regrowth on it. As Elston pointed out, this reduced habitat effectiveness is cumulative over the landscape, and there appears to be a link to pathway 1, so increased mortality risk on or near the disturbances. Range abandonment has been looked at to some degree in Alberta. There's an instance with the Alopesh herd where caribou completely abandoned their winter range and migrating down to those winter ranges, and there's high disturbance levels in those ranges. Boyan looked at boreal caribou in an intensive in situ area in northeast Alberta and found that caribou don't abandon or shift their home ranges in response to high levels of that activity, and that, you know, that plays an important gap for us, because if caribou are wanting to linger around and hang around, then there might be a higher chance of mortality. The climate change pathway, so severe weather events and spread of infectious diseases have been linked to substantial increases in natural mortality of barren ground caribou. So, for example, they'll get freeze events that will, all the vegetation will be frozen in barren ground, caribou will starve. Fire is a potential implication in Alberta. Jess Dunford looked at an amplified fire regime in Alberta and modeled if there would be an effect on caribou. He indicated from his modeling exercise there'd be no effect. They tend to stay where they are, I guess similar to the mountain pine beetle, where they'll still go back to that area. But as Kim Daw pointed out, we'll have climate change could lead to altered spatial temporal overlap of species, so more suitable habitat for species like deer and less severe weather. Climate change is a toughie. We kind of lack management tools in our toolbox, and some scientists have recommended it's more of a risk management for caribou. So just very quickly, as we head into this morning's discussion and this afternoon on research gaps, the state of the science is leading us in the direction of and as well as the recovery plan for caribou, that the ultimate cause of declines is the habitat. And in that, whether it be removal of habitat or alteration of habitat, which is playing out on reduced spatial separation with alternate prey and predators, habitat avoidance, cumulative impacts, and habitat alteration, with the proximate cause being predation, again linked to early cereal habitats, the alternate prey and those predators. So Environment Canada has identified that immediate protection and restoration of habitat and the management of predators and alternate prey is required to avoid the acceleration of population decline in many woodland caribou populations. This is a figure showing the Little Smoky caribou herd, and the dotted line is where the implementation of wolf control came in. In that range, we still need to work on the footprint. There's been some work, but there's still need, obviously. I'm just going to go through some of the thoughts on recovery and where there has been tidbits of work. I think it was Stan yesterday pointed out, Festive Bianchet, I think that's how you say the name, did a report on looking at the literature as well, and the Athabasca landscape team did this as well with a lot of modeling exercises. And without predator control in the short term, we're unlikely that many of the western woodland caribou populations will persist. So even if we stop all industrial activity, and there is a time lag of forest succession. So we're at a point in time, for example, with the Athabasca landscape team, we had to model scenarios of 50 years of wolf control while we're starting to minimize that development and aggressively restore lines before we start to see it, an ability to stop that action of wolf control. So we've taken the populations down to such a level that we do need to restore the habitat, but we have to recognize that trees don't grow very fast. With respect to habitat restoration, it's not just vegetation, it's not just getting vegetation out there in the line, but how do we define what restoration is and achieve functional habitat restoration for caribou? So at what point does the restoration on that line remove all impact of that line to caribou? Lee and Booten looked at this and identified that seismic lines within lowland black spruce showed no recovery 35 years post-clearing. So we have certain areas in these caribou habitat areas that are going to be extremely difficult to bring back. There was a Conoco-Suncor pilot study that Scott referred to yesterday looking at how wildlife are using the lines. Very preliminary, but starting to look at lines with 2 meters of growth and what animals occur on there. And you still have the alternate prey and predators selecting for those lines, even though there's around over 20 years of natural regrowth on them. So really, what's that going to mean from a caribou perspective, and do they still have the same predation pressure? Yesterday we learned about the reintroduction programs, and there have been some translocation programs. So there's been some work done on that in the science. And Snyder et al. Looking at environmental reserves and triage approach to our recovery. So just to wrap, this is the Athabasca landscape team's woodland caribou pathways summary, and looking at the ultimate cause of decline being linked to that habitat and proximate being linked to predation. So I'm just going to leave it at that.